Last week we talked about the things to really consider before installing an irrigation system, and today joining us again is Mr. James Moore.
Steve.
Hi James, welcome back.
Thank you.
James is with the water store out of Tulsa, and James, you have really been the person, I guess, the mind behind the plans here. Tell us a little bit about how extensive of a project as far as our installation for our studio gardens compared to maybe the everyday irrigation installation.
Sure. Okay. Well, our system here consists of 30 individual stations, and for the size of an area, that's an extensive number of stations. We've broken the studio gardens here down into separate areas so we could water each type of grass, whether it be fescue or Bermuda or any other type. Plus, we've divided the zones for drip, different types of vegetable gardens for planting areas, and to do that we had to break it up into very small segments, so it's been quite extensive.
Good. Well, we are excited and we appreciate all your hard work, but I think the whole purpose of doing this is not only for our benefit with watering here, but also for our viewers to really dissect a system from head to toe. And let's get started, James, about the very first thing that someone would really consider before ever starting, and what would that be?
The first thing they need to do is really talk to, there's a number you can call, and that's called the Okie number here in Oklahoma, and each state has their own number. It's a toll-free number to call, and what this number does is this notifies all the utility companies that you're going to be digging in your yard and also on the easements, and so they will come out, they'll notify all the utilities such as Public Service or OG&E or Oklahoma Natural Gas, your cable companies, and they will come out at no charge and mark your lines that are buried underground, and prevents a lot of future problems for them and for you. So that's the first thing you'll want to do is check, call this Okie number, and then get started after they come out.
And then what is the next step after that as far as connecting in and having water? Just go right on through the steps.
Well, the next step really is you'll be making your tap on your domestic water line, and this is usually just downstream of your water meter. And at this point in our system here, we've done that, but we've tapped the main line coming through here. It's a 6-inch line, and we've installed what we call a pressure vacuum breaker, and this is a backflow prevention device. It prevents any kind of contaminated water coming from our irrigation system or some other source to come back into the domestic drinking water supply.
Okay. Now this part of it is mandatory, right?
Right. This is mandatory by the state of Oklahoma. The plumbing code requires, there's 3 devices that are allowable. This is one of them. It's a pressure vacuum breaker. The 2 other devices are an atmospheric vacuum breaker and a reduced pressure device. This is sort of the middle of the line as far as protection goes.
Now the reason we have 2 is because one goes to our irrigation system, one to our existing frost-free hydrants.
That's right.
Okay. Right. Now what about insulation for the winter? What is the
box? What we're going to do is we're going to install a thermostatically controlled heat tape. We'll be wrapping around this device, and then we'll be installing an enclosure over it, basically just to knock the wind off of it and keep the heat tape working. And so this is just a 110 volt outlet box we're going to plug our heat tape into. Okay.
Now from here we're trenching and hooking up all of our pipe. Tell us a little bit about the type of pipe that we would use.
Okay. Well, there's 2 types mainly. In our part of the country, Oklahoma and Texas and Arkansas, Missouri, most of it in the southern parts use what we call a PVC pipe. It stands for polyvinyl chloride, and it's more of a rigid type pipe, but it has a very good flow characteristics. It's very smooth inside, so you don't lose much friction in it, and it's very easy to put together. And this is a piece of 1/2-inch pipe. This is a piece of 1/2-inch polyethylene pipe. We're going to see this in our drip zones later, but this pipe is rated for fairly low pressure, but what you would use if you were using this for your mainline pipe would be a little stiffer polyethylene, be a stronger pipe. But this is black polyethylene pipe.
So then either one of them?
Either one will work.
Okay.
But this is the most common use of PVC.
Okay. Well, James, let's walk around now and again get into the mechanics of the system and share that with our viewers. Let's take a look at one of the first zones. Well, Well, James, earlier you mentioned that we had 30 different stations out here. Explain a little bit about what a station is and how it all fits into the overall system.
Okay, a station is a group of sprinklers of common type that are controlled by one electric control valve. And so in this case, they'll be either rotors, which we'll go in a minute, pop-up sprays, or drip zones, but they're basically all the same type.
All right, and again, that was based on matching it up with a particular type of plant or crop that we're growing.
Exactly.
So this is a station that's controlled by a valve?
Right,
Is that right?
Electric control valve. That's this black device down here at the bottom. It's controlled, it operates on 24 volts AC, and we have 2 wires going to each valve. And these wires are ready for underground burial. In this case, with the red and the white wire are 16 gauge with the heavy PVC insulation. And we chose that for this project just based on the length of runs and the type of system we had. One option is to use a multi-conductor wire. These are 18 gauge wires in different colors, and you can run just one cable in the mainline trench and just select what color you want. One important thing with electric valves are when you install these things, or when a contractor installs them, make sure you have plenty of length to bring these wires to the surface to work on. And you'll notice these big looking wire nut looking things. These are actually waterproof connectors, and there's different types, and I'll show you a couple here. This one is the one we use. This cap is actually filled with gel, so when you twist your wires together, you continue to twist this little device on, and it goes inside this big nut and keeps the water from getting to the connection. Another type is this type right here, where you would actually put a wire nut together, put the wires together with a wire nut, insert it inside this gel into the bottom of this connector here, and then bring the wires out and snap it shut. And there's an example of one that's already done.
So you don't want to cut corners here by any means.
You don't want to cut corners. This is a problem area that if you don't waterproof your connectors, down the road you'll get some corrosion in between the copper, and they will not. The valves either not function properly or will not come on, or there'll be sporadic opening.
Now the valve is actually what is controlling that zone or station.
That's correct.
Now how would we cover those up then to protect them?
What we do is we dug about 3 or 4 inches below the valve and put in some fresh, clean gravel underneath the valve, so that any water that gets in here will flow below the valve and you can maintain and work on it. Then we put a black corrugated ADS pipe over the valve, cut notches for the pipe. We insert our wires, pull them up through the top.
And the reason that you're putting this one on first is why?
Well, this allows us to extend this valve box so we put this valve cover over the valve. It's flush with the surface, and we'll be able to get to it and maintain it later. Okay, so this valve box will merely sit over this, and then we'll bring it up to the surface with the soil, and then we can always remove the lid and get to the valve, work with the flow control, or work on anything we want to.
Now, James, what kind of heads are we going to be using on this particular type of valve? Explain those to me briefly.
Okay, this 1-inch valve is going to control the rotors, which we have in this area, this turf area. These are pop-up gear-driven rotors.
And what do they do, the rotors?
Okay, they pop up and they spray a single stream and rotate around. They'll spray anywhere from about 20 feet, anywhere up to about 50 feet. And normal spacing is about 35 feet.
Are they pretty water efficient?
They cover a large area, and their precipitation rate is fairly slow as compared to the pop-up sprays. So it puts water down at a little slower rate than the pop-ups.
Okay, it's not a fine mist that might blow as much either.
There's not as much mist, but they are prone to wind. So in the wind, you have to really watch it. It's best not to water those when it's really windy.
And then the other types?
Okay, we're running, on this type of valve setup, we're running our 4-inch pop-up sprays in our turf, in this case our fescue, and we're also running a 12-inch pop-up sprays in our annual beds back over here and here and here. So,
and the 12-inch is higher and more at an angle to get better coverage on
That's right. They're made to pop up above the plant material and then spray out over them. So.
Okay. Now, in putting in these heads, is coverage overlapping crucial or what?
Very important. In most cases, you want to have head-to-head coverage, which means you want one sprinkler to spray the other sprinkler, and that'll give you uniform distribution of your water, and that's why the manufacturers design their sprinklers.
Okay. Well, James, let's go over now and show them another type of valve box that also includes different types of systems, and
Okay.
that way we'll get a better idea of what all we have out here at the gardens.
Okay.
James, this zone is going to be used for, I guess, our containers around our barn here. What is the difference in this type of setup from the one that we just looked at?
Okay, we have added two devices. One for low pressure and low volume drip systems and micro spray systems. We use what we call a Y strainer, which filters out any particles, very small particles, so they don't clog up the small emitters, drip emitters. And also we reduce the pressure that's coming into this line right here with this little pressure regulator, and it reduces the pressure down to 25 psi.
So those are two attachments that hooked on right next to the...
on the downstream side of the valve that go towards the heads.
Okay, and a little bit different box, I guess, right?
Right, we're using a larger valve box so we can get to it. Notice the bricks, we block this valve up so that there won't be any kind of pressure on the pipe should anything heavy roll on top of the valve box at the surface. So we block it up, and it rests on that. We bring our wires inside the box as before, and we'll set a valve box extension to come to the surface. And so we'll set it like that, and that's what we have on the inside, and we'll pack our soil around it.
Well, let's talk now about some of the different examples of low pressure systems that would work with this one.
Okay.
I guess with the various low pressure examples we're going to show, they really are interchangeable depending on what crops we would use. Is that right?
That's right. Whatever crop we put in, we'll choose the drip system that's most efficient for it.
Okay. And what is the first one here, James?
Well, these are little bubblers, and they're low pressure bubblers. And if you want to turn them on, Steve,
okay.
What they do, these are stream bubblers, and they spray a half circle. And the nice thing about bubblers are the fact that they will keep a lot of water off the foliage and still give you pretty good coverage laterally from side to side. And they come in full circles and half circles and quarters, and also a flood bubbler, which just put a lot of water right around the bubbler itself.
And you can adjust the...
You can reduce how much flow comes out of the streams by just screwing this screw in here. This is an adjustable flood bubbler.
Okay. Now, James, we have our raised beds here. We fixed it a little bit differently. Tell us how that process works.
Okay, what we did, knowing that we're going to change the crops that go in each one of these beds even several times a year, we decided to manually control each bed, and sometimes there will be nothing in these beds, and so we put a manual valve to shut them off, and with our control system we'll be able to water this bed one time during the day and then water that one automatically.
Now, we had our main lines coming in here, and how did you get it in the bed to this point?
Oh, we just trenched underneath here on each bed, trenched down and came underneath the ties into our valve box and set a manual valve inside.
Okay. So again, we can change out the system depending on the type of plants that we're going to grow. And we've got another example over here. Let's talk about it.
Okay, this is a true drip system. What we have is a multi-outlet emitter with what we call spaghetti tubing going to an individual plant. And these are emitting at the rate of 1 gallon per hour, which is a very low rate, but there's some real advantages in that we're applying the water right at the plant where we need it. And it will eliminate a lot of weed problems in the future. So
now, you've got a multi-emitter there, I guess.
Right.
It comes in various types there too, right?
That's right. We can get an emitter that actually just plugs into the tube here, and we'll have some over here in one of the other garden areas. And also we have a little emitter you'd plug into the pipe here and run an individual tube over to a plant. So there's a lot of varieties.
So the pipe is already one piece, and what are you doing? Just going in and...
We're punching a hole in the pipe, and then the little emitter actually has a little barbed end on it. So it pokes through the pipe and seals off. So it's very simple, very easy way to do it.
All right, good. So that one would go right up to the plants, for example. And over here, we've got, what are these?
This is a micro spray setup. Micro sprays is also a low pressure system. This is operating right now at maybe 30 psi, but the flow rates are still very low, anywhere from 5 gallons per hour up to 20 gallons per hour. That's still a very slow rate. So you can get these things that throw a radius of about 4 feet all the way up to about 12 feet. So.
And again, the same thing, you just poke the holes in.
Right.
And
There are different types of micro spray systems, and we'll have these in different forms out here, but we poked a hole and you ran a little tubing over to it and gives you some flexibility. This tube could be anywhere out here. and just you don't have to worry about where it is as long as you have plenty of tubing to get to it.
So this particular one, we'll be using it maybe with some of the vegetables, but also some of our annual flower beds too?
Right, we're going to use it on the annual flower bed around the porch, around the building. So that's where we're going to use this application first.
All right. Now, another one that we have over in some of our ground beds is just a regular drip system too. Tell us about that one.
It's a bi-wall system, and basically you have it's a two-part bi-wall tape, and they have little holes drilled into the tape every 12 or 24 inches, whatever you buy, and it emits water at every one of those little holes, and so we have those right over here.
Where we can run them right down the row of our vegetables.
That's right.
Okay, so very water efficient. But now I can understand why the valve system with the filter is so important, because we're talking about small holes that could easily clog up here.
Very small hole, that's right. And these are excellent systems. They're actually fairly inexpensive.
Okay. And again, with interchanging them, I'm sure we've only just scratched the surface, haven't we, of the types. That could be used.
Without a doubt. We'll have about 4 or 5 different drip systems out here, types of drip emitters, so we'll see them from time to time.
Okay. Now, again, we have 30 different zones that we've talked about, a valve box at each one, controlling them all. Would you say that it's a very efficient system to try to do it that way?
Oh, it's very efficient from a water standpoint.
Okay.
Okay, very efficient.
Well, James, you've shown us some great examples of different systems. And of course, that's all the time we have today. And if you're interested, we invite you to come back next weekend, because James will be back to kind of show us the brain that's going to control this whole system. And we'll also give you some more maintenance tips on irrigation system and design. So again, join us next weekend here on Oklahoma Gardening.